Let's get started. I would like to introduce Kaizen's Regional Manager, Luis Fernando Gazcon.
Thanks for that lovely introduction, Sherry. Good day, everyone. Today, we will be reviewing our electronic assembly cleaning basics with the topic manual concentration monitoring. But before jumping straight into the topic, the first thing that comes to my head is the universal question, why? Luis Fernando, why do I have to monitor my concentration? It is a fair and very interesting question, and to answer it, we would have to jump straight into the cleaning process. So follow me. First, we have to understand the process dynamics ongoing inside a particular cleaning application. We'll be taking an inline spray cleaning process as an example. Typically, we will fill the wash tank with a specific proportion of DI water and a specialized cleaning agent. In this case, we are using our Aquinox A4625. We refer to this proportion of water and cleaning agent as concentration percentage. When you start running your process, you will typically observe losses in your wash tank. These are caused mainly by two factors. Exhaust losses, these are vapors and mist generated inside the chambers. Both chemical and water are continuously being pulled out through the exhaust system. And drag out losses, trapped liquid on the part surface and cavities, as well as through the conveyor belt. Although these are small volumes of liquid loss, when added through all the operating time of the machine, it will definitely disturb our original percentage in the tank. We will have to address this by making add-ups or top-ups periodically to keep the concentration in check. Your cleaning agent supplier should have provided you with the recommended concentration percentage range. We advise you to follow up this recommendation. Failing to do so eventually will have negative consequences in your process, impacting cleaning quality or the overall process cost of your operation. If you are above the percentage range, you could be facing some or all of the following issues. Poor rinsing. The higher concentration, the higher rinsing needs to achieve the expected results. Your rinsing could no longer be enough to finish removing all chemical and flux residues. A high concentration also could cause material compatibility on sensitive metals. Some chemistries contain inhibitors to protect these materials, but when used at higher concentrations, the product could become more aggressive and attack them. Chemical excess would eventually contaminate your rinse tank at a faster rate than expected, which will increase your consumption of DI water, resulting in a depletion of your DI beds, especially if you are recirculating your rinse, which is a very common practice in this type of process. Higher chemical consumption will impact your overall process costs no matter what. On the other side, operating at lower concentrations could be even worse. Lower concentrations means that the flux residues will not be completely removed. These residues could be left under critical components, and due to their ionic content, they could eventually form dendrites, resulting in intermittent or complete failures of the device due to shorts or current leaks. Reliability will be compromised, and you could face guarantee returns or unexpected reworks. This translates into an even more costly process than the previous case mentioned. But I know that we as engineers like to know the reasons behind everything. So here I would like to take a moment to explain why concentration can affect cleaning performance. One of the main reasons cleaning agents are required is to decrease water surface tension. And you may ask, what does lowering surface tension means? Well, this is the graphic explanation of it. The drop above is just a simple water. Below is a drop of water with an engineered cleaning chemical on it. Cleaning agents allows water droplets to penetrate under those small distances underneath critical components, enabling it to get in direct contact with the flux residue and dissolve and remove them completely. Basically, it flattens the droplets. As concentration percentage decreases, water droplets height increases. Keeping concentration in the recommended range means maintaining liquid's ability to penetrate and clean. Getting your process under control will help you avoid this type of issues. This is an accelerated video on how ionic residues like flux could react, developing what is known as dendritic growth. In order for this phenomenon to occur, you need certain conditions of humidity, temperature, and voltages. Of course, this all can be easily avoided by accurately cleaning your board. But if you cannot measure it, you will not be able to control it. So this brings us to today's topic, manual concentration monitoring methods. We will be reviewing the most common manual methods available for monitoring a PCB cleaning process. There are more semi-automated or fully automated methods available, but we will be reviewing those in a dedicated tech-to-tech session later on. So please stay tuned with our program. As my coworker, Kevin Buckner, has beautifully explained in one of our previous tech-to-tech sessions, the first step is to identify what is the nature of the chemical. Is it a hydrophobic splitting type chemical, or is it a hydrophilic homogeneous type chemical? I will not delve into each type, but if you are interested in getting to know more about it, I do strongly recommend you check Kevin Buckner tech-to-tech session named Is It My Concentration in Check? You should go and check it later on. The following are the three most used methods for monitoring concentrations depending on the type of chemical we are using, and we need to choose one of them. So the first one is a split measurement method. Second one is refractive index, where you will require a refractometer, and titration, which involves chemically analyzing the sample using an indicator and a titrant. The split measurement method is usually recommended for hydrophobic chemicals. It actually uses its separation phase characteristic to measure the proportion of solvents in the sample, allowing us to calculate the proportion of cleaning agent in the mix. For this method, you will require a sample of the wash tank solution, the instruction sheet and conversion charts, as well as the split kit with the reagent. This method will take you about 10 to 15 minutes to complete. The first step is that you will add a spoon of the Kaizen Type 2 reagent into the Kaizen graduated flask, both included in the kit. Then you will fill the flask up to the top mark with the wash tank sample solution and mix well. The reagent, the red powder in the pictures, acts as a catalyzer, accelerating and tinting the phase separation in red color for easily identification. You will have to wait 10 minutes for the separation phase to be completed, and then you will be able to measure the amount of milliliters of the red separation layer formed. Using the conversion charts, you can transform the milliliters value into a concentration reading. In the refractive index, it is best suitable for hydrophilic type of chemicals. Refractive index involves passing light through a sample of the wash tank solution. Usually, through a drop sample that you place on the refractometer, the device measures the light beam's refraction suffered while passing through the drop, and this deviation is measured in a Briggs scale. Using a Briggs conversion chart offered by your Kaizen representative, you can easily convert the Briggs value obtained into the concentration value. This will take you about 1 to 2 minutes to complete. Titration is a method more suitable for lab analysis due to the precision skills required. It can be used for either type of chemicals, hydrophobic or hydrophilic. It involves getting a sample of the wash tank solution and diluting it into a known volume of water specified in the instructions provided by the manufacturer. An indicator solution is used to tint the diluted sample, and then a titrant is added into the sample drop by drop, making sure it mixes well until the color set by the indicator completely disappears. It is very important to keep the total number of titrant drops required to eliminate the color. This number of drops will be converted into the concentration value using the indexing charts. Though this is a very precise method, it usually is not suitable for on-floor production monitoring, though it is always an option for both type of chemicals. We have come to an end, and the main points I'd like to take with you today are the following. First, concentration monitoring is crucial for maintaining the expected cleaning results in your process. Failing to control the process concentration percentage can have disastrous and very costly consequences for your process, compromising the quality and reliability of the final product and inevitably increasing your overall costs. The most common manual monitoring methods available are split method for hydrophobic chemicals, refractive index for hydrophilic chemicals, and titration for any type of both types of chemicals. So thank you very much for listening, and I send it back to you, Sherry.
Thank you, Luis. If you would like to discuss this topic further, please contact your local Kaizen regional manager or send an email to tech@kaizen.com, and we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.